Otherwise, our topic is dynamic pricing in e-commerce using a neural network approach. These are our team members: Hitesh Preet Kumar, myself Ryan Pinto, Yadvinder Singh Bullar, and Tirumal Reddy Gupta. Contents for our today's topic is abstract, introduction and motivation, neural network, dynamic pricing, problem statement, the solution, future work, and conclusion. And continue, my friend Hitesh will continue with the abstract.
Hi, here we have abstract for our project. Basically, neural network technology is a technology which is based on a human nervous system. And this technology is being used nowadays in many areas such as business and e-commerce. It helps to keep track and a balance between demand and price. We have used time-based prediction in artificial neural network. Next, introduction and motivation. Of course, there is a fluctuation in online market, hence there is a major cause for price forecasting for the retailers. Every seller wants to sell goods at maximum profit. It is ostensible that e-commerce is not an easy task as there are a lot of duties for employer to keep an eye on. Moreover, online purchasing of products has reduced communication gap between buyer and the seller. This is a great advantage for the customer to receive product at their doorsteps. Online e-commerce business has opted for dynamic pricing method and it has influenced widely over online internet e-commerce market. If we talk about e-commerce, it is a strategy that adjusts the product price in a timely fashion in order to allocate right service to right customer at the right time. Dynamic pricing have numerous examples like Amazon is using dynamic pricing, online air ticket booking use dynamic pricing. That's why the price of the tickets fluctuates after every minute, after every second. And many more online firms use this dynamic pricing. Further, neural network. This term is being derived from neurons because neural network works similarly as a human nervous system. So it's a simulation of a human nervous system. Every cell, like in the nervous system in the human, every cell receives an input and transfers it to the other cell. Similarly, in neural network, input signals are transferred to the other nodes. Hence, it can be treated as a mathematical expression, as a mathematical function where y is the output, which is the function of wi, which denotes as weight of the path, and xi, which denotes as the input of the path, whose value the value of the I varies from 1 to the n. And next, here we have a neural network. This is the basic diagram for the neural network. Every neural network have three layers, which is there is input. First one is input, the second one is hidden layer, and the third is output layer. Every input layer have many inputs. It can vary from 1 to n. Here we have input 1, 2, 3, and 4. The input of every cell node is multiplied by the path whichever it follows. The weight of the path is multiplied by the input, and after that at the output we receive it as y, as a y. And after summation of this, at the terminal node we receive the final function. Continue.
Basically, dynamic pricing is the practice of pricing item at a level determined by a particular customer, perceived by its ability to pay. It is also known as real-time pricing. It's an approach to set the cost of for a product or service that is highly flexible with respect to time and demand. And as in retail e-commerce market, the demand always fluctuates. For example, it also depends on the season. In August, whole Western world goes to holidays, which is considered as a low demand month, whereas compared to December and January, due to festival seasons, the demand is more and it's on its highest peak. The goal is to find a strategy for retailers so that they can apply to get the maximum revenue for their respective companies. For solving this problem, we have assumed such conditions and a model, deterministic model, which is based on time and date of an item. Here we initially assume that the inventory is S0, time is 1 to t, price of one item at time t is equals to p of t, demand at time t is equals to x of t. We also assume that there exists one to one relationship between demand and price at any time t. Our main focus is to maximize the revenue or profit, which surely depends on the price and the demand. So we maximize it with constraints of demand always less than or equal to inventory, and choose demand should be non-negative at any time interval. We also assume that x, which is our demand, is a product of price and time, should be continuous differentiable with regard to p, and x, which is a product of p and t, is lower and upper bound and tends to 0 if p increases to its maximum value. What we are trying to assume is we have an objective function which is a product of xt pt. We have to maximize it with constraints xt, which is less than or equals to s0. Xt is our demand and s0 is our inventory, such that demand should always be non-negative. For that, we have assumed the Conan-Tucker approach, which is basically first order necessary condition for a solution to be optimal, provided some regularities conditions are satisfied. For that, we have used Lagrange multiplier, a well-known method for solving constrained optimization problem with Conan-Tucker. The idea behind this method is to reduce constrained optimization to unconstrained optimization, and to take the constraint into account by augmenting the objective function with a weighted sum of them. As you can see in the equation, lambda, which represents the vector of the Lagrange multiplier, we will differentiate it to maximize and try to satisfy the Conan-Tucker conditions. Flexibility such that subject is equal is feasible. No direction which is approved objective and is feasible by applying Lagrange multiplier. And we, for the slackness, for completely slackness, we equate the Lagrange multiplier to 0 and positive Lagrange multiplier. With these conditions satisfying, we can our neurals and apply to our neural network, we will be able to predict our price with respect to the time and the demand, which is always positive, and we will be able to get the maximum revenue. Further, my friend is going to continue.
So here we come to the comparisons. We have the neural network models. The ones which are doing are the differential transformation 5, the rational transformation 5 fixed, the rational transformation 10, and the differential transformation 10. These are applied on the tag game, that is the trading agent competition, and the results are found out for the average error rate and the hit rate. Hit rate is nothing but whether a model follows the trend of the observed time series. Higher the value of the hit rate, more accurate is the model that follows the trend. We see here that the differential transformation 10 model has the average error rate of 5.9% and a hit rate of 89.8%, and the rational transformative 5 fixed model has an average error rate of 3% and a hit rate of 90%. These two models have the highest hit rate compared to the other models that have been applied. For more observations for that game, we see that higher for highly competitive bidding prices following previous days is sufficient for making assumptions on the winning bid orders. The analysis varies across different online model types, and more accurate solutions are achieved when following predicted prices rather than on the prices known from the previous days. Future work, we can apply other neural networks in the model to predict the accuracy of customer order requests. We can also develop a meta model that aggregates or creates a summary of different results from the different models and finds the optimum solution for the current market prediction. Moving on, my friend Tirmal will continue.
Coming to the conclusion, the neural network displays a satisfactory ability to solve most of difficult problems appeared in supply chain management. Applying neural network based models are proposed to predict customer orders prices based on the time series of these prices in the context of supply chain management. The experiments conducted show that models are able to respond dynamic changes in real time. It has been found out that differential transformation 10 and rational transformation 5 fixed model have highest prediction accuracy, although the performance might differ in different market conditions and strategies of competitors. Here are the references. Thank you.